Apa ni? Screen. Okay, 1, 2, 3, start. Good morning, Dr. Robert. My name is Nur Atika Aina binti Zalani. Today, I would like to presenting to you on how I'm run the experiment 4, which is precipitation using visual method. First of all, we look at the question. The question is, an electroplating wastewater contains 1000 milligram per liter cadmium and 1 molar H2SO4. The on-site physicochemical wastewater treatment plants use lime to neutralize the wastewater and precipitate the cadmium. For first step is using visual Minteq, predict the pH of and species distribution in the wastewater before addition of lime. Copy the pH and species into Excel. First of all, we launch our visual Minteq. Here, at the component name, we add H plus and total concentration is 2 molar. We click to the add to list button. After that, we go back to the component name and add SO4. The total concentration is 1 molar and click add to list button. Go to component name and add cadmium. Go to the concentration unit here, change unit to milligram per liter and insert the total concentration of cadmium is 1000. After that, we add to the list and we change back the concentration unit into molar. Go to the pH and choose calculate from mass and charge balance. We go to the parameter to check the default setting. So here, choose the number of iteration which is 5000 and click the last box, the last circle, which is oversaturated solid are allowed to precipitate each time a mineral precipitate or dissolve. We go to the save and quit button at the bottom of the page. And then we go to the view or edit list button. Here we change H plus to 2 molar concentration and SO4 into 1 molar concentration. Then we go back to the main menu button and run Minteq as usual. So the pH obtained here is 0.02. We copy that pH and paste into Excel. Before that, I want to state that I already paste all the data and value inside the Microsoft Excel. So here, you can see at my Microsoft Excel, before addition of 1 molar calcium hydroxide, the pH is 0.092. So I paste the pH we obtained in the visual Minteq just now here. After that, we go back to the visual Minteq and click view species distribution. Pop-up table are shown at the screen. So we copy the 2 row, Control C, and paste into Excel. So here I paste the value in the Excel. Second step is using visual Minteq, titrate 1 liter of wastewater with 1 molar calcium hydroxide. Choose suitable titration step and export the result to Excel. Okay, we go back to the visual Minteq. Back to main output menu. We go to the multi-problem or suite. Click titration box. Go to titration manager. Here, volume of solution to be titrated is 1 liter. Volume of titrate is 0.02 liter. Concentration unit of titrate is mole per liter. And click the box. Under define titrated composition, the concentration of calcium hydroxide is 1 mole and we choose Ca+, Ca+2. We can choose Ca+2 only because hydroxide does not include in this component. After that, we save and next button. Click this button and then go to the save and back to multi-suite menu button. So here, add here, state the number of titration step. In order to get 1 liter, 0.02 liter must time with 50. So we added 5 additional steps. So the total of number of titration step will be 55 steps. Add here, choose component or species for suite output. Add component species, we choose cadmium. And we want to plot the graph total dissolve. So we choose total dissolve and click add button. Then we go to save and back button and then run Minteq as usual. When the pop-up table is shown, we click to the selected suite result and copy row number 1, which is problem number, into cadmium total dissolve until the last row, which is problem number 55. Copy that, which press Ctrl C and paste into Excel. Here, I already paste the data. So, next step is between problem number and also pH, I add 1 column to insert volume 1 molar of calcium hydroxide. At B13, I add 0 liter. At B14, I add 0.02 liter. In order to get the continuous number like this until last step, I highlight B13 and B14 and double click the green box at the below of the box here, below of the column row here, below of the row here. I double click and it is automatic calculated and the number is continuously until 55. The next step is step number 3. Plot the volume of calcium hydroxide versus pH and total dissolve. Format the graph professionally. So in Excel here, I already plot the graph, as you can see here. So in order to obtain the graph like this, we must highlight the volume of calcium hydroxide, pH and total dissolve until step number 55. Then we go to the insert menu, choose illustration. We go to the insert menu. We go to the insert menu, choose graph, which chart. We go to the insert menu, choose chart and choose cutter number 1. Okay, like this. Now I explain how to create a graph to obtain the graph like this. So here, first of all, we click total dissolved cadmium concentration at the graph. Then we format it, click left mouse, double click, we click total dissolved cadmium concentration and press right click and select format data series. At the series option, we choose secondary axis. Okay. After that, we delete the grid line behind the graph. Then we format the number into black color. Format the line x-axis and y-axis into black color. So how to format it? We double click the y or x-axis line. Go to the tick mark. Go to the outside. Select measure type outside at the here. And then we do the same thing as y-axis. Outside and this also outside. Click outside, tick mark at the y-axis here. After that, we go to the line and choose the color. The color should be black. So we can see the color change over here, and do the same thing as Y and X axis left. The next thing to do is we remove the line border. The next thing to do is we remove the line border. The next thing to do is we remove the line border. Select the outer line of border and go to the border and no line. So you cannot see the line at the border. So you cannot see the line at the border. After that, we must add chart element. Go to the chart element menu under chart design. Here, go to the axis titles and select primary horizontal, primary vertical, and secondary vertical. So at the primary vertical, we change it to the pH unit. Then at the primary horizontal, we change to the volume of cadmium. Volume of 1 molar calcium hydroxide liter. After obtain the chart element, we need to insert primary vertical here pH. We need to insert primary horizontal here volume of cadmium. We need to insert secondary vertical. Here is total dissolved of cadmium concentration. So I already changed the graph like this. So this is a pH. Over here is a volume of 1 molar calcium hydroxide, and also at the secondary vertical is total dissolved cadmium concentration. Step number 4. Using the graph, identify the volume of 1 molar concentration required to neutralize 1 liter of the wastewater. We go back to the Excel. In order to obtain the volume of the pH at pH number 7, we need to sketch the line at the graph. In order to obtain the line like this, we need to go to the insert menu, choose illustration, choose shape, and select line. We place the line between 6 and 8 pH. We insert the line between pH 6 and 7. We already know the primary vertical here is a pH, so we place the line here between pH 6 and 8. To edit the line into become the red line and dash line, we go to the format shape, choose line, and at width we choose to 1.5 1.25 pt, and at dash type we choose the dash line like this, and then go to color and change it to the red color like this. So we copy the line, and sketch, continue sketch to the volume, to get the volume. Continue sketch. Continue sketch. Continue track. Okay. After paste the line, we continue drag the line down to the volume of calcium hydroxide like this. Okay, the graph look like this. So it's the same as usually can. In order to obtain the volume of calcium hydroxide, we go to the data obtained from the visual Minteq. Go until the pH change. So at C62, we can, and 63, we can see the pH change drastically. We highlight both pH. which is C63 and C62 together with the volume of calcium hydroxide, which is B62 and C63. Copy that and paste over the graph here. We need to obtain the volume at the pH 7. In order to obtain the volume, we can do some calculation, which is interpolation. Here I already shown on how to get the amount of calcium hydroxide. So the answer is 0.99 liter is the volume of 1 molar 0.99 liter is the volume of 1 molar calcium hydroxide required to neutralize in 1 liter of wastewater. Next, go back to Visual Minteq at step number 5. Reset and add again 1 molar H2SO4, 1000 mg per liter cadmium and the amount of calcium hydroxide required to neutralize the wastewater. Before we go back to the Visual Minteq to reset everything, we need to know the amount of calcium hydroxide required to neutralize the wastewater. So here I already stated on how to calculate the amount of calcium hydroxide required to neutralize wastewater. So we obtain 0.99 liter at the pH number 7. We must time with the 1 molar calcium hydroxide. So 1 molar of calcium hydroxide times with 0.99 liter, we obtain 0.99 mole per liter of calcium hydroxide. When we know the exact amount of calcium hydroxide required to neutralize the wastewater, we go to the Visual Minteq and reset everything. After reset, we add back the H plus, which is 2 molar concentration, add to the list. Then we add SO4 with 1 molar concentration and click add to the list. Next, we add cadmium. Change the concentration unit into milligram per liter and the total concentration of cadmium is 1000. Click add to the list button. Then we change back the concentration unit into molar and at company name we choose calcium hydroxide. So we cannot choose hydroxide, we can only choose Ca because hydroxide does not include in this component. Then the total concentration will be 0.99. Then we add to the list. At the pH here, we choose calculate from mass and charge balance. Then we click view or edit list. At SO4, we change to 1 molar concentration at a pH. We need to minus the H plus component minus with calcium because we add here Calcium hydroxide does not calcium hydroxide cannot include in this component name. So 1 mole so calcium hydroxide is 0.99 mole. So Ca plus will be 0.99, and also same with the OH, which is 0.99 mole. So we need to minus 2 mole of H plus minus with 0.99 of Ca plus 2. So the answer is 1.01. Then we click back to main menu and run Minteq as usual. Step number 6 is run Visual Minteq. In the result, go to display saturation indices and identify the species that have precipitated. Click on amount of finite solid to find out the concentration. So we go back to the Visual Minteq and click display saturation indices. At here, at the saturation index, we click to gypsum and click amount of finite solid. Copy the value, press press Ctrl C, and then paste to the Excel here. Before that, I forgot to mention, we need to insert together pH. So the pH obtained here is 2.958. Before, sorry, I forgot to mention pH after addition of 0.99 liter of 1 molar calcium hydroxide. So the pH after addition of 0.99 liter of calcium hydroxide is 2.958. Next step is convert the molar concentration of precipitate into gram per liter and calculate the mass of heavy metal sludge in kg produced per meter cube of wastewater. In order to change the gypsum molar concentration into gram per liter, like this, we need to know the molecular weight of gypsum. So when we need to choose the molecular weight. So the molecular weight of gypsum is 172.17 gram per mole. So here I already calculate on how to obtain the gypsum in gram per liter. So gypsum concentration must time with the molecular weight of gypsum in order to obtain the value in gram per liter. After that, calculate the mass of heavy metal sludge in kg produced per meter cube of wastewater. So here, in order to get the unit into from gram per liter into kg per meter cube, we need to time with 1000 kg divided with the 1000 meter cube. So the answer, the final answer is 167.65454 kilogram per meter cube. The next task is record task 1 until 7 as video and upload into the YouTube and submit the link and submit the link into the VLE. So I think that's all from me, Dr. Robert. Thank you. So I think that's all from me. Thank you.